Hello, I'm Martin Mosier. This is for EEE 120 Lab 1. We were asked to make 4 different circuits, a half adder, a incrementer, a full adder, and a 4-bit adder. This is the half adder. As you can see, when A equals 1, sum equals 1. When you add B to A, sum equals 0, and it carries out a 1. And when A is 0 and you add B, which is 1, sum is 1 and carry out is still 0. So that's working, so that half adder is working fine. And you can see from the waveforms, you can see from the waveforms the exact same thing. When A is 1 and B is 0, 1 plus 0 is 1, so sum is 1. When B is 1 and A is 0, same thing, sum is 1. When A is 1 and B is 1, carry out is 1 because you have 2 bits now, so it carries out the second bit and sum is 0. Moving on to the incrementer. As you can see, this is the circuit that you can see. When A is 0, Y is 0, and that carries on for everything. So when A is B or 11, Y is 11. But if you increment it, Y increases by 1. So while A is 11, Y is 12. When A is 12, Y is 13, so on and so forth. And then when A is 15, or F, Y becomes 0, and a 1 is carried out because there is overflow in the 4-bit digit in the 4 bits, so Y becomes 0 again, and you carry out a 1. Alright, with the incrementer waveforms, you can see that when incrementer is 1, and when that's Y is always going to be 1 greater than A, and you can see that when incrementer is 1 and A is F, Y is 0, because we've reached the end of the 4 bits, so it just goes back to 0, and we carry out a 1, and that represents our overflow from that kind of addition. And then you can see when incrementer is 0, A and Y is 0, and 1 and 1, when A is 1, Y is 1, and when A is 2, Y is 2, so on and so forth. There should be no carries from that part. Then we made a full adder, so when A is 1, sum is 1. When A is 1 and B is 1, sum is 0, and a number is carried out, so just like in the half adder. Now we have a carry in input, so when that is 1, sum is 1, and then when 1 plus 1, so any A or B, carry out is 1 and sum is 0, just like when A is 1 and B is 1. And then when A is 1, B is 1, and C in is 1, then we carry out a 1 and sum is also 1 because that is a 3. And in binary, that is just a 1 and a 1. Alright, with the full adder, you can see the exact same thing as with the circuit. When A and B is, and C in is 0, sum is 0, and carry out is 0 because nothing's being added. When B or A is 1, and C in is 0, sum is 1. When C in is 1, sum is 1, and the rest are zeros. And then when A and B are 1, C sum is 0, C out is 1, because you're carrying out a 1 from the addition. And then when all 3 are 1, sum is 1 and C out is 1, because you get a 1 remaining and you carry out another 1. Finally, we have the 4-bit adder. So with this, you can do signed or unsigned addition, and it will tell you whether something is overflowing in unsigned, or if it's overflowing in signed. So we have 3 inputs. We have A and B, which are both 4-bit numbers. We have C in, which can either be 1 or 0, and we have a 4-bit output. So when A is 1, Y is 1, that works like the incrementer, but then you could also add B. So when B, you add an 8, and if this was unsigned addition, we can see that this would overflow, which means that because our carry in is a 1, but our carry out over here is a 0, which means that it's an overflow. But you can see that it equals 8, that equals 9, 10, and then you can increment it with the C in. So that goes from 10 to B or 11, and then yeah, that works completely. Alright, so looking at the waveform, we were told to do some testing, so this is just the waveform of that. So we can see the test values over here. One of them is just to make sure that nothing is stuck at 1, so all of this is 0. So the C out is 0, and the overflow is 0. The sum is 0, the C in is 0, and then the 2 inputs are also 0. this was just to make sure that the CN was working. So when you input a 1 for CN, you expect a 1 in sum, which we can see right here. This was testing to making sure that that unsigned addition wouldn't just trigger the overflow for no reason. So we have 2 and 3 is 5. This was making sure that the CN was working with signed addition. So we can see that, 13 plus 1 is 15. This was making sure that overflow is working for unsigned addition. And yep, that's working. So when cout is 1 for unsigned addition, that means there has been overflow within the system. And then all of this tests, the rest of this tests for signed addition. So this was making sure that it was working, that CN was working, and that you could trigger, and that overflow is working. So yep. So you can see that when overflow is 1 and cout is 0, that is it represents a 2 right here because it is a 2-bit number, or is a 1-bit number.